everyone and welcome to this video. Kleena here, and today I'm going to be taking you through the solutions to question 8 from this Leaving Cert higher level paper. This question is a long question worth 50 marks and it's based on the topic of financial maths. So let's get started. We're told that Olga, Chen, Fiona and Rohan all have bank accounts. Olga puts €3,000 into a savings account. Interest is added annually at a rate of 2.4% per year. We're asked to work out the amount in Olga's account after 5 years, correct to the nearest cent. So to answer this question, you need to use a formula, which many of you might know off by heart, but it's also in the log tables. So the formula in question here is the compound interest formula, which is F is equal to P 1 plus I to the power of T. So I'm just going to rewrite the formula here. So that is F is equal to P by 1 plus I to the power of T. So F is the final price and that's what we're looking to find. P is the principal, which is the amount initially invested, and that's €3,000 for this question. 1 plus the interest rate, and the interest rate is 0.024, and T is time in years, and that is 5 years. So what we can do in a question like this is we can put it straight into our calculator. So we have 3,000 multiplied by 1 plus 0.024, put that to the power of 5, and you get a total of 3,377.699. It wants it correct to the nearest cent, so that's 3,377 and 70 cent. So that's our final answer for question A, and for getting this answer correct, you're going to get a total of 5 marks. The next question doesn't require any calculations. It asks us, what is meant by present value of a payment of €1,000 in 1 year's time at a particular interest rate? And what's meant by that is the amount that if you invested today would give you €1,000 in a year's time at that interest rate. So it might be, say, €850. If I invested €850 now at a particular interest rate, I would have €1,000 in a year's time. So I'm going to describe it as the amount that, if invested today, would give you €1,000 in a year's time at that interest rate. Now in the second part of B, we're told that Chen puts a different amount in a savings account with the same interest rate, which is 2.4% per year. After 6 years, he has €4,000 in the account, and we're asked to work out how much Chen put in the account initially, correct to the nearest cent. So that is his principal. We're using the same formula that we used before, but now we aren't looking for the final price, but rather the principal. So let's start filling it in. We know the final price is 4,000 is equal to the principal, which we don't know, by 1 plus 0.024 to the power of T, which is 6 years. So P is going to be equal to 4,000 divided by 1.024 to the power of 6. Let's put this into our calculator. And that is €3,469.45. And for getting the correct answer for B part 1 and 2, you're going to get yourself a total of 10 marks. Question C tells us that Fiona is taking out a loan at the same annual interest rate, but she makes the payments quarterly. We're asked to work out the quarterly interest rate that would be equivalent to an APR of 2.4%, and to give your answer as a percentage correct to 2 decimal places. So there's a certain method that you have to do when you're converting interest rates from yearly to quarterly to monthly and so on. So we know that the interest rate for the year is 1.024. We're working out the interest rate for the 4 monthly installments. So that's 1 plus I. So this is 1 plus I for the interest rate for the yearly rate. But we're going to put that to the power of 4 because it happens 4 times. Now, we want to find this I here. That's what we want to find. So I need to get rid of this to the power of 4. So I'm going to put the left-hand side and the right-hand side to the power of a quarter. When I put this to the power of a quarter, it cancels out and we're left with 1 because I multiply 4 by a quarter and that gives me 1. So now we have 1.024 to the power of a quarter is equal to 1 plus I. So the interest rate is going to be equal to 1.024 to the power of 1 over 4 minus 1. And let's work that out. And that gives us an answer of 5.9467. So I is equal to 5.9467 multiplied by 10 to the power of minus 3. So that means that we need to move the decimal place 3 places to the right. So I'm going to put in my zeros here to help me. So we need to move it 3 points to the right to get rid of the 10 to the power of minus 3. So I'm going to get rid of that first and then move the decimal place 3 points to the right. So here we go, here, 2, 3. So the interest rate is 0.0059. So that gives us an interest rate of 0.59%. So that is the quarterly interest rate. That's our answer, and for this answer, you're going to get a total of 5 marks. Now moving on to question D, we're told that Rohan wants to put the same amount of money in a savings account at the start of each month for 36 months, so that at the end of 3 years, he will have a total of €12,000 in the account. Interest is calculated at a rate of 0.11% per month. In question Part 1, we're told, taking €1 to be the amount Rohan puts in his account at the start of each month, write down a geometric series in €1 to show the total amount of money in the account at the end of the 3 years. Include the first 2 and the last 2 terms. So how you answer this question is, €1 is the amount of money that he invests at the start of each month. So let's say it's the start of the 36th month, okay, of the first month of 36 months. You invest €1. Now, you're going to earn interest on that. So 1.0011. So that's the interest that you're earning per month. But how many times are you going to earn that interest? You're going to earn that interest 36 times, 36 months. The next month, you invest A, you keep A, so that's why it's 1.0011. So 1.0011. So basically A is being multiplied by 1.0011 for every month that it's in that bank account. And the second installment, okay, that's staying there for 35 months. And so on. So once the first 2 and then the last 2. So on the second last month, you invest A, and then that's multiplied by 1.0011 for 2 months. And then finally A by 1.0011, and that's just for 1 month. So to the power of 1, you don't have to put down the power. So that's all you have to do for this question. And then the following question kind of follows on from it. It says, hence, find the value of €1 that will give a total of 12,000 in the account after 3 years. To give your answer correct to the nearest cent. So what I'm going to do here to make this easier for myself, I'm going to take out A. And I'm going to work backwards. So I have 1.0011 plus. So I'm taking this out. And now I'm taking this out. And then next I'm going to take out 1.0011 to the power of 3 and so on. So I have plus 1.0011 to the power of 2. All the way up plus 1.0011 to the power of 35 plus 1.0011 to the power of 36. And this is equal to 12,000. So, how are we going to work out A here? What we have to do is we have to work out what's inside the bracket. Now, we could sit here all day and add up all of these numbers in the sequence, or we could use the formula for the geometric sequence, okay? A geometric series, and this is in our log tables. So this is the formula in question. S of n, so the sum of numbers, okay, is equal to a by 1 minus r to the power of n over 1 minus r. So in this question, a is the first term of the series, so that's 1.0011. Or is the difference, the common difference between all the terms in the series. So that is, again, 1.0011, and n is the number of terms, which is 36. So let's find the sum of that. So it's 1.0011 by 1 minus 1.0011 to the power of 36, all over 1 minus 1.0011. So A by that equals to 12,000. So let's work out what's inside that bracket. So we have 1.0011 by 1 minus 1.0011 to the power of 36, all over 1 minus 1.0011. That gives us 36.742. So we have A by 36.742 is equal to 12,000. We want to work out what A is, what it is he invests every month. So I'm going to get A on this side, move this over to this side, and we get 12,000 divided by 36.742. And we get €326.60. So that's our final answer. And for this answer, you're going to get a total of 15 marks. Question E deals with expected value. It tells us that a park sells 3 types of tickets, and that the table below shows the information and the price of each ticket. For example, 15% of all tickets sold are student tickets. So we're told that the expected value of the price of a ticket is €13.85. We are asked to work out the value of X, the price of an adult's ticket. So there's a specific formula that you follow when you're dealing with expected value. So in this case, what you have to do is you multiply the price of the ticket, which is €11. I can actually keep out the euro sign here. So 11 by 52%, so by 0.52. And then you add, so the student ticket is €5 less than an adult ticket, so it's going to be X, which is the price of an adult ticket, minus 5. You multiply that by the percentage of that, which is 0.15. And then you add 0.33x. And that's equal to the expected value of a ticket. So that's €13.85. So all we need to do here is solve for x. It's actually quite a simple algebra question when you break it down. So 11 by 0.52, that'll give us 5.72. And then we have plus 0.15x, and then we have minus 5 multiplied by 0.15. That gives us minus 0.75 plus 0.33x is equal to €13.85. Let's keep all the x's on the left and move everything else over to the right. So we have 0.15x plus 0.33x is equal to €13.85 minus €5.72 plus 0.75. So I can add up the left-hand side. So we have 13.85 minus 5.72 plus 0.75. So on the left-hand side, that's equal to 8.88. Or the right-hand side, my apologies, is equal to 8.88. Now what's the left-hand side equal to? 0.15 plus 0.33. That's equal to 0.48x. So to find x, we divide 8.88 by 0.48 and see what we get. And we get €18.50. So that's the price of an adult ticket. The value for X, €18.50. And for this question, you're going to get a total of 10 marks. And now for the final part of this question, part F, which tells us that when an item is being sold, the markup is the profit as a percentage of the cost price, and the margin is the profit as a percentage of the selling price. It tells us that a shop sells an item with a margin of 18%. Work out the markup for this item and give your answer as a percentage. So let's write down what we know. So the margin is 18%. So that is our profit over the cost price, or the selling price, my apologies. And that is 18%. We're looking for the markup. The markup is the profit all over the cost price. Now, we're not told the selling price or the cost price, but we can work those out given the information that we have. So, because the margin is the profit in terms of the selling price, if the selling price of the item is 100%, it's divided between the profit and the cost price. So if the profit is 18%, that means that the cost price is 82%. So now all we have to do is use this formula to get the markup. So the profit is 18%. The cost price is 82%. Multiply those by 100 to then get your percentage. So we have 0.18 over 0.82. Multiply that by 100. And you get 21.95%, which to the nearest percent is 22%. So 22% is our answer for this question. And we found that by knowing that if you're dealing with the margin, that is the profit in terms of the selling price. So as I said here, if the selling price is 100%, this is our selling price here, that's divided between the profit and the cost price. And then when we found the cost price, we could then use the formula to find the markup, which is the profit as a percentage of the cost price. And so for this question, you're going to get a total of 5 marks. Okay guys, so that's all for this question. I hope you found this video helpful. Thank you all very much for watching, and I'll see you all in the next video.